Okay, so last conic section we're going to look at is the hyperbola. Remember, the hyperbola is a little bit different because it's the conic section that you get if you take two cones and put them like point to point and slice it straight down, and then look at the cross section. Okay? You'd get kind of a different looking shape. You actually get two parts to the shape that are not connected. So it's the only one that kind of looks like that. All right, so we'll start off with the definition. So I told you yesterday that the definition between an ellipse and a hyperbola is exactly the same word for word, except you change one word. So yesterday, an ellipse was a set of points in the plane such that if you measure the distance from a point on the ellipse to the first focus and a point on the ellipse to the second focus and add them, you get a constant. Well, today, it's if you subtract them, you get a constant. So you find a point somewhere on the ellipse, measure the distance from that point to the first focus, measure the distance from that point to the second focus, and subtract the two numbers. Okay, so yesterday it was the sum of two distances that was a constant. Today it's the difference of two distances. And again, because this is a figure, it's in the plane, a hyperbola is a flat, two-dimensional shape. Okay, if you take calculus, you might study some really interesting three-dimensional shapes. Like there's one called, it's a hyperbolic paraboloid, which is, if you think of like a horse saddle, it kind of looks like that. It's kind of got this curve to it in a couple directions. So you might see hyperbolas again, extending into 3D, but we're staying in 2D. All right, so here's a hyperbola. Okay. It has two parts to it. They're not called parts. I'll tell you what they're called in a minute. And point E is a point that I can drag on the hyperbola. As I drag it, the length of segment EC is going to change and the length of segment EB is going to change. But if you subtract the two, in this particular hyperbola, it comes out to 5.66. Okay? It'll always come out to 5.66 in this one. In other hyperbolas, it'll come out to something that's the same, but it might not be 5.66. Okay, so let's just drag it a little bit. Right, so you can see as I drag it, if you were to subtract those two numbers, you can check it if you want, but it will come out to 5.66 all the time. If I go over to the other part, same thing. Due to rounding, sometimes it comes out a little bit off, but if you take 10.04 and minus 4.38, you should get 5.66. Okay. So any questions on that? And it goes on forever. Obviously, you can't see it on the screen, but it does just go on with these two pieces. Like an ellipse, there's two cases. This is the case where things open left and right. You can also have the case where things open up and down. Right? So there's only two cases. And there's something that determines which case you have. Yesterday, it was where was the bigger number. You need to forget that for today. That doesn't apply at all. A was always the bigger number for an ellipse. Forget that you even know that, because that'll mess you up today. Okay, those two fixed points that we're measuring the distance to, and then finding the difference, those are the foci. So in my picture, C and B are the foci. Now, if you draw a line through the foci, what was that called for an ellipse? The name of the axis that went through the foci, through the vertices, through the center.
The major axis.
That was called the major axis. Well, for some reason with hyperbolas, they decide to rename everything. It would be great if they kept it the same, but they don't. So the name of the axis that goes right through the foci is called the transverse axis. Okay, and the way that I remember that, because the other axis is going to have a different name as well. To me, the word transverse looks kind of like traverse, kind of. Right? So if you traverse something, right, it means to go across it. If you're going to traverse the canyon or you're going to traverse the bridge, it means we're going to go across it. So this is the axis that goes across and connects the two separate pieces. Okay, it goes across. This is actually the exact same definition as yesterday. If you find the midpoint of the segment that connects the two foci, that is the center of the hyperbola. Okay, so you might have a focus here and here. And if we draw that segment in green, that's the segment that connects the two foci. Find the midpoint, there's your center. Now, yesterday, what was the name of the axis that went through the center and perpendicular to the major axis? What did we call that? Yep. We call it the minor axis. Okay. They're going to give it a different name with a hyperbola. It's called the conjugate axis. Okay. It's a little harder to keep them straight, but if you can just remember transverse, think of traverse, goes across. Right? It goes across the two parts. Okay. Conjugate axis, it goes right in the middle. So your conjugate axis, if I go back up, would be right there in black. Now those two parts, I keep calling them parts or pieces, they're actually called branches. So a hyperbola has two branches. The branches either open up and down or left and right, at least for the kind that we're going to study. Now, we've actually already studied hyperbolas before. Okay, I never really called it that, but do people remember graphing rational functions where we could have variables in the bottom? And then we had to figure out if we had vertical asymptotes and the domain and stuff like that. So if you graph y equals 1 over x, that is it's a hyperbola. Okay? It's a little different than the hyperbolas we're studying because look at the branches of it. How do the branches of that one open? Yeah.
Diagonal.
Yeah, it's like a diagonal, right? It's on like an angle. So the branch, one of the branches is up and to the right, the other one is down and to the left. We're not going to be looking at that case. Okay, we're going to focus strictly on the cases where they open up and down and left and right. But technically that is a hyperbola as well. Okay, and then the point where the hyperbola and the transverse axis cross, those are your vertices. So if I draw this in right here, that would be V1, V2. Okay, I'm going to put the foci on here because now I want to point something out that I mentioned yesterday and I said was going to be different today. So there's the arrangement of the foci and the vertices for a hyperbola. For an ellipse, here's your major and minor axis. We call that V1, V2. This would be F1 and F2. What's the difference between the placement of the vertices and foci today relative to each other? Yep.
They're inside the foci, inside or outside?
Yeah, they switch places. So yesterday the foci were inside and the vertices were outside. Okay. Today, maybe if I go like this, it would be a little clearer. Today, the foci are on the outside and the vertices are on the inside. Okay? So they switch places. Okay, so now we'll look at the two basic cases for a hyperbola where the center is at the origin. And notice how I use A and C again, just like yesterday. So the vertices are A units away from the center, and the foci are C units away from the center. Okay. In particular, this is the case where the foci are C units left and right of the center, and the vertices are also left and right of the center. So what's completely different today is we've got to figure out how do we tell if everything is left and right of center or above and below. Okay, we've already talked about how to do it for an ellipse, but it's totally different for a hyperbola. It's not hard, it's just different. Okay. So as I said, this is the case where everything is left and right, so the transverse axis is horizontal. And here is your equation. Okay, I think I've already mentioned it, I think a couple times, but what's the difference between this equation and the equation for an ellipse? Not much of a difference, yeah?
It's subtraction instead of addition.
That's the only thing that's different. You've changed this to a minus sign. And the formula that relates A, B, and C is also very similar, except you've also changed a sign there. So now it kind of looks like the Pythagorean theorem. We're not dealing with triangles at all. It just looks like that because of the letters we're using. I don't think there's a connection at all with that theorem, but don't think of Pythagorean theorem. Okay. So it's C squared equals A squared plus B squared today. Yep.
So why did you change the C and the A? Or what they're for? Is it just because they're on the outside instead?
Change.
No, in like for the foci and the vertices, like which letter goes with which one?
So changing which, or why they switch places?
Yeah.
That's just a characteristic of the shape. Just by the definition, that's just how it works.
Okay.
So the definition of the vertices basically is where the axis crosses the shape. If I kind of had to generalize it, well, just by drawing an ellipse, here is where the axis crosses the shape, and here. And then if you look at the hyperbola, this is where the axis crosses the shape. It kind of has to do with the fact that the hyperbola kind of caves in versus an ellipse is caved out, if that makes sense.
Okay.
Yeah. All right, and there's one extra thing with hyperbolas that we don't have to worry about with ellipses. That's asymptotes. So the asymptotes are going to be very helpful to figure out the curvature of the hyperbola. Okay. Basically, what's going to end up happening when you draw a hyperbola, you're going to draw these two dotted asymptotes, and they're going to create an X shape. The X shape is very helpful because the hyperbola branch is going to be contained in one of the four sections of the X shape. So let's say this was a left and a right. It would look something like that and like that. So the X shape is going to give you an idea of how to draw the branch. Okay, so it is pretty helpful. And these particular asymptotes go right through the origin, okay, if you don't shift it. And the slope of the asymptote is B over A. So there's no extra calculation you have to do to find the slope because you're already going to have to find b over a anyway. We're just going to use them as a fraction to write the slope. I'm not too worried about that. This is the same as what we discussed yesterday. A is the distance from the center to the vertex. C is the distance from the center to the focus. Now, I put absolute value because in the fraction, now you have a negative. So I don't want you to think like B is a negative or A is a negative. Right? When we're thinking of the distance between the center and the vertex, you should always think of distance as a positive number. Okay? Now, I don't want to jump ahead too much, but it is kind of important. I want to show you what can switch places today. Okay. Yesterday, it was the x and the y. All right, that could, or I'm sorry, it was the a and the b that could switch places. Today, never. This is always going to be your a squared. The second denominator is always your b squared. It doesn't matter which one's there. That doesn't matter at all. First denominator is a squared. Second denominator is b squared. What does switch places is the x and the y. Okay, so you don't have to write that. We're going to get to that. Okay, but I'm just showing you what switches places today. Just the x and the y. Right? And the way you figure out which way the transverse axis goes is look at the first one. That's how you figure out which way it goes. The first one is always the positive one. So another way to say it is, whichever letter is the positive, that's the direction of the transverse axis. Okay, so let's go back to ours and just look at it again. The first one is x. That's a positive. The second one is y. It has a negative. Positive is the direction of the axis. Okay? That's how you tell for a hyperbola. Okay, that's pretty much it. So now we'll just do a few different examples. Somewhere I give you the equation, somewhere you give me the equation, and then eventually we'll try some shifts where we have to find h and k. Okay, so the first one says find an equation of the hyperbola. And we'll graph this one. I think it's probably the only one I'm going to graph, but we'll practice graphing one. All right, so based on the information that they have given me, what can I find first without really doing any calculations? Rebecca?
A and C.
Yep, I can definitely find A and C. So A is the distance from the center to the vertex, which in this case is, yep, 2. Yep. So distance is 2. C is the distance from center to focus. How far apart is the center and the focus? Yeah, 3. Now for the formula, we really need b squared, but we can find it using this. And J, and what's the formula for that again? C squared equals?
A squared plus b squared.
Right, a squared plus b squared for a hyperbola. Okay, so we get 9 equals 4 plus b squared. So if we solve that out, we're going to get 5 equals b squared. So b is the square root of 5. As far as the significance of b, if you were actually sketching it, I'm not 100% sure. For an ellipse, it's the distance to the minor axis. Not sure that there's that same significance for b today. Don't worry about it. Bless you.
Thank you.
All right, so we've got A, B, and C. Last thing I need is my asymptotes. It's going to go right through the origin, so I don't have to put a y-intercept. What's the formula for my slope? Yeah? Yeah, so it's b over a. Square root of 5 over 2. For the purposes of graphing, I really need to change square root of 5 to a decimal so I can look at my rise over my run. So square root of 5, I think, is about 2.2. Okay, so we'll kind of keep that in mind. Okay, I already had the asymptotes, but we'll go through them. All right, so the first one is up 2.2, right 2.2. So we'll go up 2.2, I'm sorry, right 2. Then we'll go up to 4.4 and right 2. Okay, and you can keep going. If you want to go then 6.6, so it would be 6.6, right 2, about like that. It's not, whoops, wait a minute, I was off on that one. Up 1, 2, 3, 4, 5, 6.6, right, oh, I didn't go right 2. That's why. Okay, so there's our first asymptote. And now we'll go down 2.2, right 2. So down 2.2, right 2. Down to 4.4, right 2. And then we'll go down 6.6, right 2. About right there. It's a little bit off. It's not bad. Okay. Any questions on asymptotes? All right. So now we know the center is 0, 0, so we can graph that. Or if you want to put a dot to represent it. What else? The vertex is negative 2, 0. Where else do I have another vertex? 2, 0. Okay. And now, as far as sketching it, just try to draw a curve. Stay inside the left and right part of the X shape. Make sure your curve gets closer and closer to the dotted lines as you sketch it. So something kind of like that. And on the other side as well. Yeah, it's as good as I can do. So that's what your hyperbola looks like. If you wanted to kind of remove everything in the background so you could see it for a second, I can just show you what you're really looking at. So that shape in red, that is your hyperbola. Questions on that? It's a little harder to draw than an ellipse, but the mathematics behind it really is very, very similar. All right, so let's look at this one. All right, so this says to discuss. So now, in addition to telling me the vertices, the center, the foci, the direction of the transverse axis, I also want to know the asymptotes.
For the last problem, it said find equation and graph, so we didn't do the equation yet.
Oh, we didn't do the equation. Yes, we can do that. Thank you. So we're going to have a fraction equal to 1. The first denominator is always a squared. The second denominator is always b squared. That never changes. What does change is where you put the x and the y. I want the transverse axis to go horizontal in this case. Horizontal is the x, so make the x positive. And that's your equation. Yep, thank you. Any questions on the equation? Yep.
When you determine the x squared or the y squared, which one goes first? Can you do that before graphing, or do you have to graph?
Oh no, you could do the equation first. In fact, for every problem we do the rest of today, I'm not going to graph any of them. So I'm just going to find the equation if that's the kind of problem it is. Yep. All right, so now here's one where they're giving me the equation. Notice it's the same family in terms of how the branches open. X is the positive. So let's just start with identifying A, B, and C. Shauna, what's A in this case? Yep. A is the square root of 16. Dylan, what's B? 2. And C is the square root of A squared plus B squared. It's the square root of 16 plus 4, so square root of 20. Which we can simplify. Square root of 20, what does that reduce to? 2 square roots of 5. Okay. And we're good. So now we'll describe everything. Okay, center. The center is at the origin. Just like an ellipse, you'll know when it's not at the origin because the numerator is going to have subtraction or addition in it. Okay. So center is at the origin. It's always the first thing. The second thing you want to figure out is the direction, which I think I already mentioned, but can someone tell me again how you can tell the direction of the transverse axis? Yeah.
Since the x term is first, you know the transverse is horizontal.
Yep. Whichever one is positive. Now, if they did something tricky like this, normally you would not want to do this. But technically, that's the same equation. And you'd have to be very careful because it's always the positive one, which in this case, for some reason, they wrote it second. I would rewrite that the top way if they did something like that. Okay? All right. So transverse axis is horizontal. All right. Vertices. Gracie, how far are the vertices from the center? Yep, the vertices are 4 units away. In this case, in the horizontal. That means left and right. So my vertices are going to be positive and negative 4, 0. Megan, how far away are my foci? How far? They're 2 square roots of 5 units away, again, horizontally. So it's positive and negative 2 root 5, 0. And now the one extra thing we need is the asymptotes. Okay, I'm going to give you a trick to remember the slope because for now the slope is b over a, but you can probably guess what's going to happen when the transverse axis goes the other way. It's going to flip. So it's for now it's 2 over 4. Positive and negative. And just like any other fraction, if you can reduce it, we should. That would be a much nicer one to graph. And on the test, if I gave you one to graph, it would probably be more like that. Okay. Any questions on finding all that? Okay, let me make sure. Did I actually do the whole problem this time? Yes, I did. So that was a discuss. We can start this one if we need to go through the whole thing, we can, but there's just something a little different about this one that you'd have to fix. What do you have to do here to discuss it? We had to do this with ellipses.
Yep, divide by 36.
Yes, you have to divide everything by 36. Because whether you're dealing with an ellipse or hyperbola, it always has to equal 1. So that would give me x squared over, oh, Abby?
4.
Yep, x squared over 4 minus y squared over, yep, 9 equals 1. The x squared term is positive, so it's going to be exactly the same kind of problem as this one. Does anyone want me to go through and discuss that from here? How to find A, B, C, and then everything else? Okay, so it'd be just like the last one. All right, so now let's look at the case where we're still at the origin, but now everything's going to go vertical, okay, up and down. Okay, so C still represents the distance from the center to the focus. A still represents the distance from the center to the vertex. Okay, it's kind of nice that at least those two things stay the same all the time. But now the transverse axis is vertical. And the way we're going to know that is if it's written in standard form, it's the first letter. That letter tells you the direction. If they did something tricky, look for the positive letter. Okay. So notice, first denominator is still a squared. Second denominator is b squared. A and b do not switch in a hyperbola. Ever. Okay? Just always write it in standard form with the subtraction sign between them. It'll just keep life a little easier. The relation between a, b, and c, still c squared equals a squared plus b squared. And now the asymptotes. Still a line through the origin, because the asymptotes always go through the center. So if you shift the center, then the asymptote does not go through the origin. Okay, but for now, it still goes through the origin. And the slope is a over b. Okay, the way I remember it is, if your transverse axis is vertical, your slope is a over b. Vab. That's how I remember it. Vab. Okay, so if your transverse axis is vertical, just remember VAB. V-A-B. A over b. If your transverse axis is horizontal, your slope is b over a. Hubba. It doesn't quite have the same ring to it. But VAB, I think that helps. So VAB, a over b. Okay. So any questions on any of the information there? The coordinates, the formulas, the trick to remember the slopes? Okay, so we'll try a couple examples of this, and then we'll look at the case where we shift it. All right, so this is another discuss. Let's go through and do it, even though we already did one, because this time it's going to be a little bit different case. Okay, Tessa, what would I have to do first here before I'm even ready to find A, B, and C? Yeah, we're going to divide everything by 4. So that's going to leave me with y squared over 4. I know normally if a fraction doesn't have a denominator, we don't put it. But I suggest in this case you put it as a 1, just so you can remember A and B equals 1. Okay, so let's start with A. Sam, what's A in this case?
2.
Yep. A is 2. B, Juliana?
1.
Yep. So square root of 4, square root of 1. And C is a squared plus b squared. So C is going to be the square root of how much? Okay. 5. Okay. So now we're ready to discuss it. I wouldn't do them in this order. What's the first one that I always suggest to find? The center. Everything is based around the center. So if you don't know where the center is, and you say, oh, the vertices are 2 units away from the center, well, it doesn't really help. So let's find the center. In this case, Trevor, where's my center?
0, 0.
Yep, we'll know when it's not 0, 0. It'll be very obvious. Tanya, which way does my transverse axis go?
It's vertical.
It's vertical. The y is positive. Okay, whichever one positive is. So now I know where the center is, and I know everything is above and below it. So now I can find what I need to find. I guess technically you could do the asymptotes. Those are kind of separate. But in terms of the top 4 things, do these 2 first. Okay, vertices. Shauna, how far away are the vertices from the center? 2 units. And they're above and below. So what would be 2 units above the center and then below the center?
0, -2, and 0, 2.
No. So your vertices are 0, plus or minus 2. Dylan, my foci, how far away are those from the center?
Square root of 5.
Yep. And they're vertical, so above and below it. So what would be my coordinates there?
0, plus and minus square root of.
Yep. So we've got those. And the last thing is my asymptotes. Gracie, what's the slope of my asymptotes when they're vertical?
Looks like the back, so it's 2 over 1.
Yep, VAB, A over B, 2 over 1. I'm fine if you just want to write y equals plus or minus 2x. So there's your asymptotes. Okay. Questions on that one? All right, so that was the case where I gave you the equation and you told me a bunch of stuff about it. Let's try one where I tell you about it and you tell me the equation. Okay, well, Stan, what's the first thing that I want to find, or what first things I want to figure out here before I can find the equation?
The second. No, wait. Which way it goes. Which one's going.
Okay, we can figure out which way it goes right now if we want. We have to figure that out eventually, whether we do that now or later. It doesn't matter, but sure, we can do that now. Which way does the transverse axis go here? Is it up and down or left and right? Megan?
Vertical.
Yep, it's going to be vertical. So I'm just going to put that off to the side because that's going to control, well, actually, you know what? We can write this now. If it's going to be vertical, you know it's going to look like this. You got to make the y positive. Okay. What are the next two things that I need to fill in that formula? I need to know.
A and B.
I need A and B. Well, A I think I can get. The distance from the center to the vertex is 2. But I can't get B directly, but they did give me enough information to find C. So what's C?
C is 3.
C is 3. So if C squared equals A squared plus B squared, C squared minus A squared is B squared. So what's B going to come out to in this case? Julia?
Square root of 5.
The square root of 5. Okay. So now we always know the first denominator is A squared. Second one is always B squared. So 4, 5, and you're done. Any questions on that one? Does anyone want to see how you would type that into the calculator? Because if it's not shifted, it's not as bad to type in. Once you shift it and get the denominators or the numerators having plus and minus, it gets kind of bad. All right. So to type this in, I have to do two things. One, that has to go to the other side by adding it. And then 2, I'm going to multiply by 4. Okay, so I'm going to start with those two things. So I would have 1 plus, in parentheses, x squared divided by 5. Okay, so that's just shifting what's in red to the other side. Now I need to times all that by 4. So I'm just going to put times 4 on the outside of parentheses. I could distribute it if I wanted and make it 4 plus 4x squared over 5, but I'm just going to leave it. And now that's what y squared would equal. So the last thing I'm going to do is take the square root, but I'm going to do the same trick I did yesterday. So I don't have to type this in twice. I'm going to take the positive square root of what I typed in y1, and I'm going to take the negative square root of what I typed in y1. Okay, so now if we graph it, this should be a hyperbola that looks something like this. Should be a vertical transverse axis. Let's do zoom 6. The center should be right at the origin. Okay, so we got a hyperbola. Oh yeah, no, that's right. Yeah, I was thinking it was the wrong way. Yeah, but the vertical the transverse axis should go across the two branches. And if you look closely, the distance from the center to the vertex looks like it's 2 units in each direction. That's what was supposed to happen. And then the foci are just imaginary points that the branches bend around. Okay, so that's the only way you could graph it, 2 separate pieces. Any questions on discussing? Do we need to do another discuss? That's actually easier because it's already equal to 1. All right, so these are the formulas that are in your book, okay, or in your packet. They are on page, let's see, page 407. And now these account for shifting the parabola left, right, up, and down. So there's the big difference in the equations. Notice how they write the relationship between A, B, and C. If I make it a little bigger, it might be easier to see. I write it as C squared equals A squared plus B squared. They got B squared by itself and moved the A squared to the other side, but it's the same thing. I would just remember it the way I showed you because I'm thinking you already kind of know C squared equals A squared plus B squared from Pythagorean theorem. So it might make it easier to remember. The asymptotes are a little different. The slopes are the same. If I scroll back to the left, when you're vertical, your slope is A over B. But what they've done is they've written it using point slope form. That's what that is. Point slope form. So if you wanted to change it to y equals mx plus b, you could do that. But the formula they give you is in point slope. And I think the reason that they write it that way is because it would look kind of messy if you put it in y equals mx plus b. You'd have to distribute out the a over b. So now you would have positive or negative ax over b plus or minus AH over B in parentheses, and then you would have to do a plus K. So if you wanted to, you could write this distributed out and then plus K and get it in y equals mx plus b. But it's just as easier to leave it like that. So I don't really even think about all these different formulas. I just think in my head, okay, the center would have been at 0, 0 if I've shifted it right 2, up 2. All right, now it's at 2, 2. So you can try to think of all this stuff, but it might make it more complicated. This is really what you need to think about, the equation box. Okay, and then down below, they just give you a couple pictures showing the vertices and foci, just like I've done before. And then the asymptotes and the branches. You don't really need to draw the sketches. Okay, so any questions on what we're looking at there? Just like if they give us one that's been foiled out, we would have to complete the square to fix it. And it would be exactly like completing the square for an ellipse. No different. Okay, so let's try this one. Let's find the equation of the hyperbola where the center, focus, and vertex are given. All right, let's figure out which way the transverse axis goes right away. So your center is right 1 down 2. Your focus is right 4 down 2. Your vertex is right 3 down 2. They're all down 2. So which way does the transverse axis go? Yep.
Horizontal.
It's horizontal. So that's enough information that I can start to set up my equation. I'm going to have something squared minus something squared equals 1. And since the transverse axis is horizontal, what letter do I want to be positive? Negative? X. So this is going to be X. That's going to be Y. Okay, other than that, now I need to find A, B, C, H, K. How about Gracie? What's H in this case? 1. And K, Sam?
Negative.
-2. Jan, how about A, distance from center to vertex?
That would be 2.
2. B, we can't really find directly, but C I can. Leo, what's the distance from the center to the vertex?
2.
Center to, yeah, I already asked that question. Let me try something different. How about the center to focus?
3.
3. All right. So now the only thing I need is B. So C squared equals A squared plus B squared. It seems like 5 keeps coming up all the time today, but that's just the way it is. Okay. So we got B is the square root of 5. All right. So if we go back and look at the formula, H always goes with X. K always goes with Y. X with H, Y with K. So it's X minus H, X minus 1, and then Y minus K. So Y plus 2. And Abby, my first denominator is always what letter squared? Yep, it's always A squared. Second denominator?
B squared should be 5.
B squared, which is 5. And that's it. There's your equation. Any questions on? Okay, so the last one we're going to do is going to be a discuss. It's going to be a little bit harder because this time it's not going to be written in standard form. We're going to have to get it that way by completing the square. It's not as easy as just dividing through by a number, which when it's not shifted, that's all you have to do. All right. So neither variable is ready to complete the square here. When you want to complete the square, the coefficient of the squared term has to be what number? Yeah, it's got to be 1. So for the x's, I'm going to factor out a -1. Leave a little bit of room there because we're going to complete the square. All right, and for the y's, how about Dylan? What am I going to factor out for the y's?
4.
Yep, I'm going to factor out 4 y squared minus 4y. Leave a little bit of space to complete the square, and let's put the constant on the other side. Okay, we did a lot of stuff there, so we should double check that everything looks good. X plus 4y squared minus 16y. Okay, that looks good. All right, Gracie, what am I going to put in the first box to complete the square there?
1.
Yep, I'm going to put a 1. And Sam, in the second box? I'm sorry, Sam. Yep, it would be a 4. So now, carefully, can somebody tell me what did I ultimately do to the left side? Yep. What do you mean 15?
We added 15.
Yes, we've added 15 to the left side, so we need to add 15 to the right. And now everything from here should kind of flow nicely. Okay, we factor that. We get x squared plus 1 squared, but we have a negative in front. Well, we kind of talked a little bit about this, but we'll see what happens in a second. Plus 4 times y minus 2 squared equals 4. Okay, so 2 things that are wrong with that. Can someone tell me one thing that's not right? Yeah?
I have a question.
Yep.
When we added 15, can you show me like where you got that from?
So here we subtracted 1,
Oh, okay.
and here we added 16.
Oh, okay. Okay. Now I got it. Thank you.
Yep. I accidentally had an x squared. I erased that. That wasn't right. Okay, what? 2 things that are wrong here. Yeah.
Well, the negative term should be the second term.
Right. This should switch places with that. So let's just flip that order. So we have 4y minus 2 squared minus x plus 1 squared. And the second thing I need to do is, yep,
Divide by 4.
divide by 4. So it took a little bit of work to get it the way we needed it, but now it's good. So we get y minus 2 squared over 1 minus x plus 1 squared over 4 equals 1. All right, so let's go through carefully. Jay, and what's h in this case?
2.
Negative 1. So h is always the one with x. That's why I wanted to just go through carefully. So, and he figured out, it's minus a minus, so we got to be careful because it became a plus. So h is negative 1. I do agree that k is 2. A is 1. B is 2. Square root of 1, square root of 4. And then c is square root of 5. Okay, so vertices. They are 1 unit away from the center. Oh, where's the center? HK. Negative 1, 2. So let's do that first. Now I know they're 1 unit away from it, but right now I'm not sure. Should it be 1 unit up and down or left and right? So let's figure out the transverse axis. Which way does the transverse axis go? Okay, Sam? Vertical, because the y is positive. So now I know my vertices are 1 unit above and below the center. So I'm going to get 1 unit above, 1 unit below. My foci are square root of 5 units above and below. Since the square root is kind of messy, I'm probably going to write this as a plus or minus. So there's the coordinate of my center. Now I need to shift it up, square root of 5 units, and down. Okay, and the asymptote, remember, it's really just point slope form. So in algebra 1, you wrote it like this. Y minus y1 equals m times x minus x1. Okay, so my asymptote is y minus, and now for the coordinate that you use, you just need a coordinate that's on the hyperbola. You can really use anything you want. Okay, you've got 2 vertices, so use, actually no, for the asymptote, I'm sorry, we want to make sure that it goes right through the center. It doesn't go through the vertice. So we have to use HK. So yeah, we got to use the coordinate for the center. All right, my center is negative 1, comma 2. So that's like your x1 and y1. So y minus 2 equals, vertical is a over b, that's your slope. So 1/2 times x minus, now you need the other part of the coordinate, -1. And there's the equation of your asymptote in point slope. If you wanted it in y equals mx plus b, just distribute out the 1/2 as a positive and add 2, and then distribute out the 1/2 as a negative and add 2. Okay, but I'm not going to go, I'm not as super concerned because most problems you're not going to have to find the asymptotes like this. But I might ask you to definitely find these 4. Okay, any questions on that? Okay, so that finishes up conic. So we're done with parabolas, we're done with hyperbolas. Tomorrow we'll start chapter 10, and then we'll finish it on Thursday. Okay, homework is very similar to last night. There's a few matching in the beginning, a few where you're at the origin for the center, and then a couple where you're shifted off the origin. Okay, so it's 13 to 16 all, and then the rest is odd. So 17 to 21 odd, 29, 31, 37 to 41 odd, and 53 and 55.